Hi everyone, I'm Suprabhat and let's begin today with Chinese remainder theorem. In a nutshell, it can be said as a mathematical concept that provides a way to solve a system of linear congruences. Let's first begin with the origin of Chinese remainder theorem. So it has got its name as it is believed that this theorem has been founded by Chinese mathematician Sun Tzu. Although there is also another belief that it was already known by Indian mathematicians like Aryabhatta and Brahmagupta much before Sun Tzu, like it's mentioned in their books. So that's about the origin. Now let's see what is the technical definition of Chinese remainder theorem. It basically states that if we have a linear congruence of the form, which is x congruent to a1 mod m1, x congruent to a2 mod m2 up to x congruent to ak mod mk, where a1, a2, ak are integers and m1, m2, mk are pairwise relatively prime, means for any value of mi and mj, their GCD should be 1. So if it follows these two conditions, then there exists a unique solution of x, which can be defined as x is equal to a1 m1 capital M1 inverse up till ak capital mk inverse mod m. We'll see about these capital m's in the uh, next slide. So let's say we don't know what is this capital m's are, so we'll first find the capital M value. So capital M, which is mentioned at the end, is basically just the product of all the small m's. Now let's see what all these capital M1 and capital M means. So first we will start with the capital M. So capital M is just product of all the small m's like M1 into M2 up till the Mk. So that's about the capital M. Now we have to find all the capital Mi like the capital M1, capital M2 up till capital Mk. So this can be found dividing the capital M with the small mi, like so this is it's such that this mi into the capital Mi into small mi should be equal to the product of all the small mi's. Now let's see what it means by the capital Mi inverse. So it basically states that when we multiply capital Mi into the capital Mi inverse and take a mod of that with the small mi, it should give a mod value of 1. It means it should give a remainder of 1. So mod operation can just be said as that if c is equal to a mod b, it means that when we divide a by b, it should get a remainder c. So in other words, we can find mi inverse in the way that we will start with a mod value 0 and mi inverse value 0, and then we will first increment mi inverse to 1, and then we'll multiply it with the mi and we'll check if the mod value comes 1. Until the mod value comes 1, we will keep incrementing it and we'll try to find it, and until we find the mod value 1, so that is our value of the mi inverse. Now let's begin with an example. So our example is a system of three linear congruences where x is congruent to 1 mod 2, x is congruent to 2 mod 3, and x is congruent to 1 mod 5. So here we have our value ai as 1, 2 and 1 and mi as 2, 3 and 5. Now we will have to find the values of mi inverse and their product. So now first we will find the value of capital M. So capital M is just the products of all the M1, M2 and M3, which will be 2 into 3 into 5 is 30. So we will fill that into our value as 30. Now we'll find the capital Mi value for each. So as we know that capital Mi is capital M divided by small mi, and we have m1 is equal to 2, m2 is equal to 3, m3 is equal to 5, and capital M is equal to 30. So from there we got m1 is equal to 30 divided by 2, 15, m2 30 divided by 3, 10, m3 30 divided by 5, 6. So and now we will fill this data into our table, like we got 15, 10 and 6 as our capital Mi values. Now let's see to the capital Mi inverse. This is going to be a little bit longer. So as we know that capital Mi inverse is basically such that when we multiply it with the capital Mi and divide it with the small mi, we should get 1 as the remainder. So we'll first start with the m1. So capital M1 is 15, small m1 is 2. So as from the algorithm that we see earlier, so we'll start with mod 0 and m1 inverse 1, and we'll multiply with the it with the capital M1 and take a mod of the 2, and here we got our remainder as 1. So as the mod value is 1, so hence the capital M1 inverse is also 1, because for that value we got the mod value 1. Next, for the M2, similarly we have value 10 as the capital M2 and small m2 3, and so we'll start with 0 value of mod and M2 inverse value with the 1, and we'll multiply with 10 and and divide it with 3, and here we see that its remainder will also be 1, because 3 into 3 9 plus 1. So from as we get the mod value once, hence the M2 inverse is also 1 only. Similarly, we will find it for the M3. So capital M3 is 6, small m3 is 5, and we'll start with the M3 inverse as 1. And first we'll multiply 6 into 1 and divide it by 5, and in the initial time only we'll get a remainder 1, and as we get the mod value 1, so our M3 inverse will also be 1. So we will fill all the MI inverses as 1, 1 and 1. Now we'll find the product as this needed for the equation AI MI inverse, and as you can see it just that. So AI 1 into 15 into 1 15, similarly for 2 into 10 20, and 1 into 6 6, and taking a sum of all of them is 41. Now let's find the x. So as we know, as we have already found these values a1 m1 m1 inverse and their sum, so their sum was 41, and we have our m value as 30. So we'll just divide 41 by 30, and we'll take what its remainder is, and as we know its remainder is 11, so the value of x will be 11. So thank you for watching this video. Please like and subscribe to my channel. Thanks.